Welcome to presentation 29. Today we're going to be talking about reading from the FAT32 formatted HCSD card. The prerequisite for this presentation is presentation 28. I usually don't have prerequisite, but for this one in particular, I think it's important that you view presentation 29. So the SDHC, as I noted before, is part of our layer 3, and we're going to be using from layer 2 the UART framework, SPI framework, IO port framework, and also from layer 3 we're going to use the display capability. So the agenda for today. So first I'm going to give you a description of the FAT32, show you how that flows. Next we'll get into a sample program, and finally we'll have a summary. So let's get started. So this I was trying to represent the FAT32 file system. And if you look at the file system, what you have is a master boot record, and with the information on the master boot record, you can access what's called the boot record. And with the boot record, you have enough information to get to the root directory and data. Now, when we create a file, what we have is a file name. And what happens on this system, the file and the file name gets stored on the root directory. So when we get the HDS card, our goal is to navigate from the master root directory all the way to the data, and the only piece of information that we have is going to be the file name. So with the file name, we need to get to this point and find our data. So how do we do that? So the first thing we know is that the master boot record is in sector 0. So we take our card and we read sector 0. With the information of sector 0, we can get to the boot record. Now, in sector 0, you have a table which is called the master boot record, and that record contains the location of the boot record. Now, the boot record has a table that is going to provide enough information from you for you to navigate to the start of the root directory. So far we haven't used the file name. So don't forget we're doing all this, but actually our goal is with the file name to go and get our data. So we're right here. We haven't used the file name yet. So the boot record is going to have the size of the reserve sector. If we know the size of the reserve sector, that's going to get us from the boot record all the way to where the first FAT table starts. Next, the boot record also has the number of FAT tables and the size of the FAT table. So with this information, we boot record, we added the reserve sector size, we got to the first FAT. We know the number of FAT tables and the size, so that gets us to the root directory. And once on the root directory, I'm going to show you that's where the file name comes into. It's important to know, comes into effect. That's what we use from this point on. We're going to do our search based on the file name. So let's see how we do that. Let's go to the details. Okay, so we have our card, and what we're going to do is read sector 0. So we already know how to read a sector from what we learned in our prior presentation. So in sector 0, you're going to look for the master boot record. That's where you're going to find the master boot record, I should say. And at the offset of 1C6, that's where you're going to find the boot record location, which is the 4 bytes. So in offset 1C6 hex, that's where you're going to find the area how to get to the location of your boot record. So let's see how we do that in our program. So this is a routine that I've called get master boot record. The sector number is 0, so we know it's master boot record is 0, and that when we get that's where we have to start, because that's the only thing we know how to read to start with. So we read the sector number 0, and then this is going to place the information of the whole sector is going to be placed in an array that is 512, and it's called sector. It's a global variable. And we already learned how to do that. So from the array sector, we're going to extract the parameter located at 1C6, 1C7, 1C8, and 1C9, which corresponds at decimal value 457, 56, 55, and 54. Now we're going to take those 4 bytes and we're going to concatenate them into one number, which is it's going to be called the start boot record. So we have these 4 bytes and it's the boot record location. So we're going to say start of the boot record, which is going to get us here. And then what I do with these 3 lines of code is I just display the information on the laptop. Because our sample program, we're going to display information on the laptop and also on a local display. Okay, so now we know how to get here. So let's continue. Okay. So this is get boot record. So we're going to get this boot record. And by the way, this is what the boot record looks like. Now, all this information, I got it from the FAT32 spec. I mean, I didn't want to show it here, but there is all over the web, you find these FAT32 descriptions. So we're right here, when we say read SDHC sector start boot record, that's going to load the whole sector into the sector parameter. So now we have an array of 512, which is a global array, as I noted, that we filled it up with this record using the SDHC sector, which we learned the prior presentation how to do that. And then from here, the parameters that we're going to be interested in are going to be the sector per cluster, reserve sector, number of file allocation tables, reserve sector, number of file allocation tables, and then number of sectors per each FAT. So we get up here, then we go down. So let's don't forget that what we have is the name of our file, and we want to read it. So far, we haven't used any of the name. We are just navigating to the point where we need to get to the root directory. So we read this whole table, and it says at 0D, E, and 10, we're going to find these parameters. 0D is going to be the sector per cluster. It's just 1 byte. So we do, sorry, 0D is 13, sector per cluster. 14 is reserve sector. Reserve sector, so we have 2 bytes that we have to put together for the size of the reserve sector. It's going to get us all the way up here. Here we have the 2. Sectors per FAT. Sector per FAT, we have 4 bytes of the sectors per FAT. And so let's put together. So now we have all our parameters. So let's concatenate our numbers. So and now these are global parameters. So we can use them in the next other routines. So we have sector per cluster, reserve sectors, concatenating these two most significantly significant. We have number of FAT, which is number of FAT tables, and then sector per FAT table. So we have, with these parameters, enough information to add from here all the way to get us to the root directory. So let's do that. So get the boot record, that's routine that does this particular thing. Okay, so let's use the information that we got from the boot record to navigate all the way to the root directory. Okay, so the root directory is going to be, we have sector per FAT multiplied by the two FAT tables that give us this area. Reserved sectors gives us this much, and then the start of the boot record gives us where we start. So we start right here, then we add all the information to get us to the root directory. And here, the last thing we do and get root directory, we read the root directory. So we got here where we know our data resides, and now we have the whole directory right here. Now we have to figure out how do we find our data. So all we have is the name of our file, and we want to get to our file and read it. And there can be number of files here, and there can be allocated to any sector. So let's see how we do that. Okay. So the cluster number, the definition of cluster number is going to tell you where your data starts. So somewhere around here, it's my data, and the cluster number is going to tell me where it starts. Now, one thing that I have to, now, inside this root directory, I'm going to have two things. One is going to be the file information tables, and my actual file. At the beginning here, we have the file information table and follow our data. Now, the file information data is going to give us the information we need so we can access our data. So, to find the file information, this is where the file name starts, it has a meaning. So, the file information table has the file name, file extension, file attributes, reserved, time created, date created, starting cluster number. That's where we have to get to be able to, that's where our actual data is. And then the file size in bytes, how large our data is. So let's go back here. So the cluster number, that's, as I noted, where our data begins. We get it from this item, starting cluster number. So we find this table, we can find the starting cluster number. Now, one thing peculiar about the cluster number is that the clusters 0 and 1 are reserved. So when we look at the cluster number, this number here, we have to subtract 2 to actually get to our cluster. Now, what we're going to do is we're going to start here, and then we're going to figure out what's the cluster number and how big each cluster is, and that's going to get us to our data. Now, the root directory was previously calculated, which is our current location. So we know this. Next, the number of sectors per cluster is defined in the root record, which we already did. So we have that information. So let's see how we get our file. So our file, first we go to our file information table, and we get the starting cluster. Now the starting cluster, we have to subtract 2. So that's where we are in the cluster, but we need to figure out how many sectors per cluster, and that's going to get us exactly to where our file is. But we start adding, starting from the root directory. So we start from here, and then we add the number of clusters, and that gets us right there. A number of sectors, I should say, so it get us right there. So we want to figure out what sector. So clusters times sector tells us the number of sectors, and then we start from here, add our sectors, and then we read our sector. We got our data. So let's figure out how we do that. Okay. Now, the directories, each of these directory has 32 bytes. So just add the information here, we have 32 bytes. So I'm going to go and start at 0 and look for my file name. If I don't find my file name there, then what I'm going to do is I'm going to go and add 32 bytes and get the next file information and read the file name. So every 32, so I got my sector, my 512 sector, and every 32 I'm going to check to see if I find it has the file name that I'm looking for. If it has the file name, then I know that I have to, from that point on, I need to add hex 1A to get to the starting cluster. And then once I get to the starting cluster, then I can go ahead and use my formula to get the location where my file is. So let's see how we do that. So I know my string, my file name, the length of my file name. By the way, this reading text file takes the file name. But before we get to this point, we have to be able to find. We had to find all the parameters, the root directory, starting sector, and I show you how you navigate to get there. You cannot use this. You have to start from sector 0. You navigate all the way to your root directory, and here we are. So I read the root directory, and the information is located in sectors. So what I do is I take my first 32, which is file information, gives me the first table located there. I get the first table and then compare it to my file name and see if, if the file name is same as what I have in the file table. And if it is correct, if it's not correct, then I keep looping, grab the next 32, and now I know the string length, so the length of my string of the file name. So every time I get one of these tables, what I do is I compare for the string size, the size of the name, to make sure that the whole name is equal. So once I get that, then I record the offset. So I'm recording exactly where this file information system is with respect to the root directory, because this 512 contains the whole root directory with all this file information table. Okay, and then once I find, of course, the file information table, then I have the starting cluster. So let's so here where I'm going to come out of this loop is with the offset. So I know where, let me back up. So when I do my loop, I'm going to find out which of these, what's the starting location for this file information table right here. And from there I have to jump to the file location. Okay, so let's continue. So I found my file information, and that's what I call the offset, where this start of this table. So the first thing I'm going to do is I'm going to send to my laptop, and then when when I show the program in the output, you're going to see, so I'm going to take to my UART, I'm going to send I'm going to go to the sector, I'm going to do my offset, and then I'm going to look to get the file name. So the size of my file name, I know where the tables, I know where this starts, the file name, which is the offset. Then I'm going to loop, and then you're going to see on the outputs of our program that the actual name shows up. After that, I get the bit 26, 27. Those two numbers I'm interested to get the starting cluster. The starting cluster is 2 bytes, 26 and 27. It's 1A is 26. I concatenate those two numbers, and now I have my cluster number. Now I send that information to the laptop just for troubleshooting. So start of my sector is going to be the starting cluster -2, because I noted that the first two clusters are not used. Then the sector per cluster, because we actually read sector, we don't read clusters. So we need to figure out how to translate clusters into sectors, and that's what we're doing here. Clusters times sectors, that tells me what sector, and I am in the root directory. So root directory plus these sectors tells me where my data starts, starting text. So what I'm going to do, once I get that information, I'm going to use the read SDHC sector. So I'm going to go and read this sector. Now, once I read that sector, now that's where I found the contents of my file. This is what I was looking. So then I go ahead and send the contents of the file to the laptop, and then I'm going to send it to the display. So let's go to a sample program. So don't forget, we know sector 0. Then, so we have the master boot record, then we go to the boot record, then we go to the root directory, we find our files, and then we navigate to our data. This shows you the connection that we're going to have. We're going to have the ATMEGA 328. The only thing I didn't show here is that we also hooked up to the serial to the laptop. So we have the color display, and this is a 3-volt display, so we have to make sure that we use something to accommodate the 3 volts. So when we hook up, this is the SPI connection. So I have SPI to both the SD and the color. So what I do is I share the MOSI clock, and I also would share the MISO, but the display doesn't use it, so I'm not sharing it, but I should. And so I share these 3 variables, and then I'm going to have a chip select for the SD, which is going to be the SS. And then I'm going to have a chip select for the display, which is going to be the LCD chip select. So typical SPI, we share everything except for the chip select, and that's how the SD or the display knows it's communicating to the ATMEGA 328, because the 328 selects the SD or selects the display. So let's look at the sample program. So it says read the master boot record, extract information needed to access the boot record. To get information, we go from here to here. Read the boot record, extract information needed to access the root directory. So we get here, we got to the root directory. Read the word test. This is the text actually that I wrote here. File and displays content in the laptop via the UART and also on the 240 by 320 LCD. So let's look at the code. Okay, so in the definer things that I want to show you, the first thing is that I have something called UART routine. That's where I have all the code for the UART. So you need to go back to our UART presentation to see how that works. Next, I have the framework SD. That has all the code needed to send all the commands. That's what we did in the prior presentation. Said all the commands needed to read sectors from the SD card and initialize the SD card. Next, we have framework LCD ILI 9341 write. That has all the code to write to the display, which we've already done in the past. So here you can see also in our architecture, these things that we use to support, I just include them. So let's look at the code. We have one routine, which is the SPI master. I need to do this at this level. Then we have the main. We initialize ports, we initialize the UART, we know how to do that. Then we have a little UART message, hello world. Then we initialize the SPI as master, initialize the LCD, that's all here. We initialize the SDHC, which we did last time, and it's a lot of code to do that, so I didn't want to include it here, but it's included right in this routine. And then in this routine, the SD, you also have the get master boot record that I already showed you how it worked. The get the boot record, get directory, then I input the file name of the text file we're looking for, which is word test, and then we read the file. But don't forget that we cannot do read the file till we've navigated from the master boot record to the boot record and to the root directory. At this point now we can say read the file name, we blank the display, and now this is a hello world for the 2x2 for our little display, and here I send information from the whole sector to the display. So let's look at the output. So hello world, then the start of the boot record, sector per cluster, reserved sectors. Then we have the number of FAT tables, 2 sector per FAT table. Then we get to the root directory. The start of our file is going to be this location and the file name. Remember I showed you this, I'm actually with this word test, I'm writing it, not from the input we got to the routine, but from the actual directory. And then we have the starting cluster, and then what I wrote was this message was successfully read from the SD card, confirming that the program can read data from it. So I navigated, giving a name, I navigated to this location and I read what was there. So here I did the same thing from the display. We have the hello world. This message was successfully read from the SD card, confirming that the program can read data from it. So the important thing at this is that we learn, okay, how do we navigate? Where do we start? Okay, so we have FAT0, where do I start? Well, I go to sector 0, and then I'm going to get a table from there, and that's going to help me navigate to a different location where I'm going to get another table, and then blah, 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 and eventually I get to my data. Okay, so today's summary. So the first thing we did was read the master boot record. So we started with a file name, which is what we want to store or we want to read. And it's okay, if I want to read it, how do I find it? Okay, first we go to location 0 and we get that record. We read that sector and then get the record. Next, with that information, we went to the boot record. And from the boot record, we got enough information to get to the root directory. And then we read the file information tables. And finally, we access and display the contents of our text files. So the important thing to understand is that you have a file name, and you're going to need to have a place where to start with 0 information. And then you need to be able to navigate to the place where you can actually start using your file name. So anyhow, I hope you've enjoyed these presentations. Thank you very much for taking the time to listen to me. And I hope to see you soon.